Hey, thanks, Christina. My name is Marc Mercuri. I lead Product PM for Blockchain Engineering, and welcome to Build Live. I'd like to introduce my two guests here. We have Vitalik Buterin, co-founder of the Ethereum Blockchain.
Hello.
And we also have Marc Russinovich, CTO of Azure. So thanks for everyone for joining us. I know we just came from another session. If you missed our VS Code demo, you can go to aka.ms, whack blockchain VS Code, and you can see a demo of that going right now. But we're going to get some questions. We're waiting for folks to come in. And as they come in, I've got a couple questions to get started. Marc, in that last session, you showed confidential consortium framework, which is huge, right? So you showed 60,000 transactions per second. You said the team can get up to 150,000. You're the guy behind that. You started that. So can you tell us a little bit about how that got started and where that came from?
Well, so it's related to our work that we've been doing at Microsoft, both Microsoft Research and then Azure, on something called confidential computing since back in 2014. This idea that we can create enclaves that are black boxes, effectively protected by hardware or software from outside tampering. And I started to get interested in blockchain and cryptocurrency, learned the basics of it, and as I learned more about it, saw things like the proof of work algorithms that consume a lot of energy and slow down transactions, and even some of the other consensus algorithms that really don't provide the same latency and throughput as a centralized database. On top of it, it's complicated to get confidentiality in blockchains. You can do it with certain techniques like zero-knowledge proofs, but complicated to set up, complicated to manage, very kind of difficult to dynamically update permissions for access. And so marrying confidential computing with blockchain resulted in confidential consortium framework, which was previously known as COCO. We launched it as confidential or CCF framework. It launched on GitHub now, and it's integrated with Quorum. I demonstrated that in the session. So what we can do with a blockchain like Quorum is drive very high throughputs on transactions per second with very low latencies with flexible confidentiality. And so you can take and integrate it with other different kinds of ledgers. And so that's kind of the result of about a year and a half now of engineering work between Azure and Microsoft Research.
And people can go ahead and download that today, right? On GitHub.
It's on GitHub. There's documentation. There's technical paper that describes the protocols and the code that you can download, build, and run wherever.
Excellent. So on the topic of scale, Vitalik, on the public chain, you and I were talking to a young man. He was actually a high school student. He was filing patents. He was working on his company that was actually using state channels. And so I know there are some folks that are probably new to state channels that might be just getting access to Solidity development for the first time working on Ethereum. Could you talk a little bit about state channels and what they do and how they can benefit developers?
Yeah, so state channels are a layer 2 technology that sits on top of the blockchain, but where the basic idea is that you have a channel between two parties, and these two parties can send many transactions between each other, but these transactions don't go on-chain, right? They just mostly stay as messages between the two parties. And there's only 3 cases in which you actually need to send anything to a blockchain. One is when you're putting funds or putting assets or whatever into a state channel. The second is when you're taking things out of a state channel. And the third is when there's a dispute. So when one of the two parties basically either kind of maliciously tries to break the thing, or it gets hacked, or some other really exceptional thing happens. So most of the time, you could have thousands of transactions happening. You could imagine these being micropayments. You could imagine them being rebalancing a financial contract. You could imagine it being all sorts of things. And most of the time, even though the interactions are all protected by the ability to put the state on the blockchain if you need to, most of the time you don't actually need to put any of those individual transactions on chain. So scalability increases by a huge amount.
So one of the other technologies that people have talked a lot about recently is Plasma. Do you want to talk a little bit about Plasma?
Yeah, so Plasma is the other big category of these layer 2 technologies that kind of sit on top of a blockchain and rely on the blockchain for security, but don't actually put things onto a blockchain unless there's disputes happening. And the way Plasma works is a bit differently. Basically, the way that it works is that you have some Plasma operator, and the Plasma operator gathers up a lot of transactions into a block and only publishes a root hash of a block, so just a 32-byte hash, no matter how big the block is, onto the chain every time there's a block. And there is this smart contract mechanism that basically ensures that if the Plasma operator does something wrong or disappears or anything happens, then if you legitimately own some object inside of the Plasma chain, the contract ensures that you have the ability to convert that into an object that's running on the underlying public chain. So I think Plasma is interesting because it allows you to get a lot of the benefits of decentralization fairly quickly with like fairly few of the costs, basically because you can run something that still looks like and works just a server, and you could basically take any existing application that runs on a server and like potentially kind of plasmify it, and it gets you these higher security guarantees, but otherwise it just keeps working the way it did before, and the if actual like incremental costs of running the thing are very low because the number of transactions you're pushing onto a public chain are very small.
So it sounds like whether it's a consortium network with TCF or the technology we just talked about, state channels and with Plasma, the concerns people may have had in the past about scalability for blockchain are really a thing of the past, or quickly going to be a thing of the past.
Yeah, no, I'm definitely very optimistic about scalability at this point.
So let's shift to a topic that comes up all the time. I do executive briefings for our customers all the time, and someone comes in with a really great idea, and you're like, that's a great idea, but it's not a blockchain solution. So a lot of times a database will do just fine. So what are the scenarios that you've seen people say, hey, this sounds like a really good blockchain idea? It's like, hey, that actually is better suited for a database or more traditional style application than blockchain.
Yeah, so the principle that I think defines what is a good scenario for blockchain is you've got multiple parties. You've got some transactions or workflows that they participate in with one another, and there's no single entity that they trust or want to turn management of the tracking of those transactions over to. So if they did, then that's where a centralized blockchain, or centralized database would be suitable. But in the case where you've got a bunch of parties, they're all effectively peers, and they don't want some middleman to operate the ledger. They can operate it in a decentralized way and do their transactions and get kind of visibility across them. Is that a kind of case where blockchain could play a role?
So one of the things that we were talking about here is decentralized versus centralized. And so if we look at, as much I think we'd all love everyone to run everything in Azure, the reality is that a decentralized solution, if maybe with 30 different members of a consortium, at least one of them is going to be running maybe on-premises or something like that. So as you look at that, networking and identity becomes super important, especially federated identity and networking. Can you talk a little bit about some of the things we have in Azure and how people might be able to leverage those for those sorts of scenarios?
Well, so yeah, if people want to leverage higher level identities, I mean, obviously identity on blockchain is really represented with a cryptographic key. Right. But what we recommend customers do is they protect that cryptographic key and put it behind some other identity system that grants access to the use of that key. So in the case of Microsoft technologies, it would be Azure Active Directory with the key stored in cryptographic HSM, like Azure Key Vault. And so you can then give somebody access to, or permissions to leverage the key that's stored in Key Vault to go sign transactions. You can revoke their access at any time. The key's never made available directly to them. And so that would be a more secure enterprise kind of approach to leveraging identities and key management. So
let's shift to a scenario for a second. So one of the things that comes up a fair bit is media, right? And so people say, hey, I've got these, I want to attest that this media file has not been tampered with. I want to go ahead and, you were talking about that in your last session with clinical trial details. But you don't put media on a chain, right? So Vitalik and Marc, what are some of the sort of best practices you would recommend for people looking at that from a solution scenario? So media doesn't belong on the chain, does it?
That's right.
Yeah, I mean, like putting big hulking like PDF music or video files or whatever onto a chain is a terrible idea because the chain's just not big enough to hold that stuff. Like if you want to use the chain to authenticate files, then generally the technique you would use is you would take a hash of the file and put it on the chain, and then if you wanted to verify it later, you would just check the file you received against the hash, and if it matches, then that's the same file.
Yeah, one of the things I liked about the demo that you had, Marc, is you hash the file, you hash the metadata of the file, so people didn't take the file and then maybe say it was their own, which imagine if you're doing like photography and things like that. And then you also did OCR on the file, and you hashed the OCR data as well. So it was the image was the same, the content in the image is the same, and the metadata was there. And so regardless of what vector you're looking at, you had attestations across the board.
Exactly. Yeah.
So we talked about what not to put on the chain in terms of media. Let's talk about IoT. And so devices can, so IoT plus blockchain is an area that a lot of people are interested in. One of the things that comes up a lot is we talk about provenance, so how did this good get from point A to point B? But there's also what are the conditions, so temperature and humidity, and you demonstrated that in your session as well. But should you put all the IoT data on there? How should people think about when they should, what IoT data they should be putting onto the chain?
Well, generally what we've seen is that a specific shipment, for example, would be represented by an instantiation of a smart contract, a shipping smart contract that would have ownership and transfers and keep track of the state of the shipment, like the humidity and temperature it had been exposed to and whether it's in violation or not. And so the example that I showed and talked about, which we've seen companies like 3M support, is for asset tracking and for keeping track of the fact that the pharmaceuticals being shipped are within boundaries, is have smart packaging that is got its sensors on it, and the IoT device that it's talking to has access to the smart contract and can fire events into the smart contract to say, hey, humidity violation on this particular instance of a shipment. And so that shows up in the blockchain. Everybody can see it. Everybody knows exactly where it happened. When you hand it off, you know that that it's that segment of the supply chain where the issue happened, not downstream. And so this is really transforming the way that tracking down problems in a supply chain and making sure that goods and services arrive at a destination in a approved state, healthy state, can be tracked. And it's a great consortium example because there's lots of different parties on the supply chain. It's not just one entity, especially if you've got a group like Starbucks working with the coffee suppliers and the different consumers of those coffee shipments from those suppliers.
So let's talk. You mentioned Starbucks, so let's take a pivot on that a little bit. One of the things I love about their scenario is they say, hey, you know what, we want to help the farmers. We want to help the farmers at the first mile. They may not know where their coffee is going. They may not be getting a fair price. It's hard for them to get credit. And so there's this whole topic in blockchain. One of the things that I'm happiest about that I get to come up and work in blockchain every day is this notion of blockchain for good, like where people are leveraging blockchain to provide value to people. And you guys travel around the world probably more than most people in this room and talk to people about blockchain all the time. What are some of your favorite like blockchain for good scenarios that you might talk?
I mean, I think one of the ones that's kind of somewhat underrated is the really dumb one, which is like, I visited Africa about a week ago. There was a hackathon there, and I actually asked the local African community like what interesting things are happening like with Ethereum there. The first answer that they gave is just people are using cryptocurrencies to work remotely for first world companies and like just be able to remit the money back to where they live. Sure. And even just that, like it just seems providing such a huge amount of value for them. And aside from that, I know there's projects there that are trying to replicate, like in places like Africa and India, like they have these different names for this in all of their local languages, but these financial or credit systems that are based on these kind of local community mechanisms. So you have groups of people that all kind of put their money into some kind of pot, and like there's rules for when people can take it out and when people are supposed to put it in, and they try to replicate these kinds of things on blockchains. Insurance is also interesting. Like I know there's projects and EtherRisk is doing some of them. Like there's one in Puerto Rico, there's one in Sri Lanka. They're providing things like insurance for floods, hurricanes, like droughts, just things that are very easily verifiable. Because if you have something that's very easily verifiable, it's like, and that there's a lot of internet data feeds for, you can just take that and turn it into a smart contract that's like a few lines of code, and like boom, you have an insurance system.
Well, on that, so we had talked to some customers about that too. And so for folks who are unaware, in a place like Africa, you have smallhold farmers. They have like less than 2 acres of land, and they might make $365 a year. So it's not economical for an insurance company traditionally to give them insurance. Mm-hmm. And so what Vitalik was just talking about, you have access to data. And so if you know that their farm is here, and you have satellite data that says, and with AI, you can say drought or no drought, you can automatically cut them a claim for that. And so you've got sort of this attestable process, you've got attestable information, and you can just remove this sort of heavy piece, which is claims for them right now. And then they could go for something that was impractical to profitable pretty quickly. Now, Marc, what are some of the scenarios that you're seeing in your travels with customers?
Well, one of them is related to this whole space, and I think Vitalik touched on it, and that is businesses in Africa. Yeah. So doing transactions with other businesses outside of Africa. And typically what they have to do is get credit, loans from banks, and actually the process to go and get a loan from a bank,
right,
for if you're an entity in a country like that that might be in Africa, is extremely onerous. And so very few of them actually get approvals to get loans from international banks that would allow them to do cross-border payments. So that's where cryptocurrencies can come into play, is to help them do transactions outside the country. The other place which we're involved with in Microsoft is digital identity. So with the UN's ID 2020, standing up digital identity, and that is also aimed at serving some of these people that are in parts of the world where they don't have strong identities, where they don't have, they've got skills, but there's no record of the skills that they've got. So when they go apply for jobs, it's very difficult for them to prove that they've got the requisite skills. So with digital IDs and the wallets that go along with them, this is where they can carry around attestations of, this is me, and I've got these skills, or I've got these certifications, or I've got this history and experience, and then leverage that to go get employment. And so that's where the local infrastructure just does not support keeping track of those things or attesting to them.
Well, yeah, for that particular, the ID 2020, what was interesting to me, and I'll admit I was ignorant of the fact, but you know, you have someone who's born in a refugee camp. They could live their entire life there. They don't have a nation. They don't have an identity. And so how do you build up the things you would do in sort of a traditional democracy there? And so this was going to be super helpful for them. I think there's lots of things like that. I've even heard, I know Consensus is here, and they've done some work in Brooklyn for tokenizing energy from people that have solar panels. And so what I thought was really cool is, like, if there was a women's shelter, an after-school program, you could actually donate your energy for them to do some interesting things. So even whether it was far away or even in our own backyard, we're seeing some really interesting things come through. So one of the things we have customers talk about a lot is, hey, how secure is this? And we were talking about the DAO earlier today. And I think at the end of the day, like, bad code is bad code, no matter what language you put it in and where you deploy it. In the blockchain space, there's this notion of code verification. Or contract verification. Do you guys want to talk a little bit more about what that is and how that's helping people in these scenarios?
Yeah, so there's a few different kind of families of ideas here, right? So the underlying goal is basically to just try to ensure that contracts do what we intuitively expect them to do, and not just like do things that are like sudden, crazy, and unexpected, like have a hold that lets attackers steal 3.5 million Ether from them. So the simplest thing that you can do is just like manual audits, and there's plenty of companies that are doing manual audits. Going kind of a step above that, like basically you can kind of just start adding more layers of automation, right? So aside from audits, you can have testing, you can have tools for things like automated test generation. There's tools for static analysis, and tools for static analysis just tries to go beyond just like running the contract with one specific input, and it tries to say, for any input or for any input within some range, like what are some properties of this program that I can prove? And then you can go into higher and higher levels of abstraction, and then there's these formal verification tools that let you basically kind of express claims about code in a mathematical language. So you might express a claim that says, like, if this number goes up by some amount, then this other number goes down by the same amount, and that could be used to represent some kind of validity condition of a currency transfer system. And you could express these conditions, and then it would use like automated mathematical theorem provers to try to prove whether or not the code actually satisfies those claims. And like, this has been done for quite a few contracts, and it seems to be a pretty good way of really cutting down the possibility that there's serious issues in code.
So in the last session, we talked about this VS Code extension, and we said we ship software every day. You talked about debugging. One of the other things we're going to be adding is contract verification as well. So really looking forward to seeing how people leverage that.
Well, I want to say also that Ethereum has a great paper on guidance for writing secure smart contracts and safe smart contracts. Really, I mean, it's a pretty long document, but it talks about all the pitfalls that have been seen out in the wild. I think is a great resource as well.
Yeah, I think that's GitHub Ethereum Wiki safety.
Yep.
Yay, hosted on GitHub.
Yeah.
Part of the family now, joy.
So DevOps, and so a lot of folks in here as a developer audience, DevOps is not going to be anything new to them. But now we're doing DevOps in a consortium. So historically, I developed on my local machine. I do my tests. I would check in. I would go through a pipeline. But now I'm in a consortium of 30 people. And so I may have consortium A, B, I'm sorry, a member A, B, C, D, and E, and E has built an app on this, and B has built an app on that. So what sort of new tools do people need for that? Can they use the existing tools? What about Azure DevOps, Marc?
Yeah, I mean, Azure DevOps is certainly part of it. In fact, we've got a white paper, too, that provides guidance for developers that are writing smart contracts and want to ensure that they go through a valid test process, that that they follow the governance for the consortium on updating smart contracts. Versioning is a key consideration as well, because like you said, there might be a smart contract that needs to be upgraded, and how do you preserve the existing smart contract addresses that applications are built on top of? So this is where registers come in for smart contracts where you can version. So all of these are kinds of considerations for creating enterprise-grade smart contracts.
So just on the enterprise grade for a moment. So a lot of customers have processes that exist already. They're running Dynamics, they've got Office, they've got, you got multi-billion-dollar banking institutions using FTP of files, or getting an attachment on email. I like to say the enterprise is messy. How does that work with the blockchain? Do we need to go all in and move everything over right now? Is it a gradual process, kind of like going to public cloud was, or?
Yeah, so I actually showed some demos of some of the things that we've got to support integration, because blockchains don't live in a vacuum. It's not, here's the blockchain and smart contracts are operating in isolation. They're interacting with outside systems inherently. And so when you talk about an enterprise, and those outside systems could be a Dynamics database. It could be a SQL database over here. It could be a workflow over in this other part of the business. So with logic apps, with Flow, the Ethereum Logic Apps connector, the Ethereum connector for Flow, it's really easy to integrate, and we've got integrations for Ethereum, more coming for different ledgers, those external business systems with things that are happening on the blockchain. So both directions, actually, of integration, where the connectors, based off of, hey, some file shows up in a SharePoint folder, let's go fire an instantiate smart contract and deploy that in the blockchain, to blockchain transaction just occurred, emitting some event. We want to kick off some workflow based on that, like the humidity out of bounds event for a device or a shipment could kick off a workflow that says, hey, this is the mitigation process we're going to follow for making sure that thing never arrives in the hands of a consumer. So those are the kinds of examples that, in really just a few minutes, actually, it's so powerful to use Logic Apps or Flow to create these integrations.
So we're now integrating with existing systems. And so a question for both of you. We talked about IoT data. All of it doesn't belong in the blockchain. Media doesn't belong in the blockchain. We've got GDPR. We've got we've got PII. What are some other things people should not be putting into the blockchain when it comes to data? And how should they look at, if they can't put it in the blockchain, how do they make sure that it's testable? How can they leverage the blockchain in those scenarios?
Yeah, I think like the two biggest no-nos are probably private data and too much data.
Yeah.
So I mean, we pretty much covered that. Other things the blockchain doesn't provide, one big one is like extremely low latency, as blocks just are going to take like more time to confirm. Like in Ethereum right now, it take about 15 seconds. In the future, it'll go down a bit, but it's never going to be as fast as one computer. So, like if you want a blockchain-based thing that has very low latency, then that's another actually a reason to use payment channels, because with channels you can have the same security guarantees as a blockchain gives you often, but the guarantee comes as soon as you receive the message.
So let's talk about scenarios again. We've talked about blockchain for good. We talked a little about, hey, with the transaction speed you have around financial services makes a lot of sense. Provenance is an area, Starbucks has talked about that. In addition to, we had Starbucks, we had Xiaomi yesterday. Are there other people you're seeing using the blockchain for Provenance type scenarios? Any interesting things you're seeing there?
This is the sort of area where I see kind of lots of proof of concepts just constantly popping up, and I myself honestly haven't seen anything live yet that I find super impressive, but I'm sure there's things kind of working in the shadows diligently, as there always are. Yeah, I mean, if the Starbucks thing pans out, that'll be really interesting.
So there's one that I saw, actually we saw a couple of scenarios of this in the justice and public safety space. We think about with evidence, there's this chain of custody and you've got a mixture of media and other documents and things like that. And so that was one where a bunch of companies came in at the same time asking us about it. But going back to, hey, we want to make sure that it's decentralized. We've got hashing on the chain. There's technology IPFS, Interplanetary File System. Can you talk about that? So for people who want to have the storage distributed as well?
Yeah, so the IPFS is this kind of collection of technologies, and it's basically trying to create a decentralized way of looking up and accessing files. So one of the core ideas of IPFS is that instead of addresses of files being kind of server-based, so like something.com/something, which is basically saying, go contact this server over there and tell him this magic number and he'll give you the file. Instead, it's like content-based addressing. So you just like ask whoever, like, hey, here's a hash of the file. Do you have the file that has this hash? And you don't really care who gives it to you. So then on top of that, like they're building the things like distributed hash tables and these mechanisms for searching for files, and then you can have layers for actually storing the files. So like IPFS definitely doesn't kind of solve every layer in its current form. So like if you want to like store files and get and get them backed up for a long time, then like Filecoin might be the right choice for that, or like Swarm, which is one of the kind of Ethereum's sub-projects, is also something that we're working on for that. But it's, you know, like the sort of thing that it's useful for is basically like if you just have a file and you wants to have that file stored either for kind of public consumption, so there's a lot of users that would need to download it, or for your own backup, like it can serve both use cases. Yeah, you can do that.
So we're talking about Ethereum, but there's really sort of two Ethereums, right? There's F1 and you're hard at work on F2.
Yeah.
Can you talk a little bit about F2 and sort of what some of the drivers are for that and sort of the key components?
Sure. So the two biggest parts of Eth2, one is proof of stake. So we have a proof of stake consensus algorithm called Casper. So we love proof of stake because it's much more energy efficient than proof of work, much cheaper to run, also potentially stronger security properties. The other big part of it is sharding. So this is massively increasing the base layer scalability of public chains by potentially a factor of about 1,000. And the way it does this is basically by, instead of requiring every node in the network to process every transaction, you actually distribute the work. So you would just assign some random subset of nodes to verify each batch of transactions. And by doing that, like if you have more nodes in the network, then your scalability goes up.
Excellent. So let me shift gears for just a second. Someone asked me yesterday, Marc. One of the things with the new tools we have, they work with the public chain, and not just because Vitalik's here, because we believe in the public chain. But they said, hey, your tools connect to the public chain, and the tools themselves are free. You don't make any money when people develop for the public chain, I don't think. Why is Microsoft doing that? Could you speak to that a little bit?
Yeah, I mean, if you take a look at a bunch of things Microsoft's doing, we don't make money off of things like VS Code. And so it's in the same spirit of that. When we go and talk to enterprise customers, there's a larger business problem. We want to make it possible for them to get going with that business problem and not have to worry on the low-level mechanics. And so what this does is make it easier and faster for them to get up onto a solution. And we figure if we're there working with them, giving them technologies, understanding their problems, showing them how to integrate with higher-level systems like we've talked about, that they could potentially be a Microsoft or Azure customer, deploy their nodes on Azure, deploy their consortium on Azure, take advantage of the other things that we've got there. But at the heart of it, too, is that enterprises are actually demanding open technologies that they can leverage wherever they want to. And so CCF, while that runs in Azure on our SGX servers, you can take CCF, the Confidential Consortium Framework, and run it on your own SGX servers. Now, we hope that Azure is a best place to do that, and that the other benefits that Microsoft and Azure provide mean that customers will do that here. But if we said created something that's like, you can only run it in Azure, and you have to pay for it, obviously that's going to limit adoption, especially in the blockchain space, which is made up of consortiums where some customers might be Azure customers, other ones want their nodes to run in their own data centers on premises.
So we're just wrapping up the session, but there's a great question there. So can you, from one of our viewers at home, that's Tanya Janka, could you please name a few security best practices for blockchain?
Yeah, so there's different kinds of security on the blockchain. So, like, there's different kinds of risks you want to guard against, right? So, like, for example, if you the risk you want to guard against is the risk of bugs in your smart contract code, then there is that safety page that I mentioned. There is also all of these like different code verification tools and like auditing processes and things that you can go through. So there is an entire kind of list of things that you can do. If you want to secure assets, then one thing to look into is that you don't really want to store large quantities of assets in a single private key, because a private key can easily get lost or it can get stolen. Like, you want to have some kind of smart contract multi-sig solution, and that like the Ethereum Foundation, for example, stores the bulk of its funds in a 4f7 multi-sig wallet, and like most big projects do something like that. So you can do things like that. Also, it's when you're building an application, it's important to just kind of reason explicitly about like what security properties you're trying to provide. So this is basically just a question of like, why are you using a blockchain in the first place, and actually make sure you're getting the benefits that you claim to be getting.
Excellent. So I think that's a great note to finish up on. Vitalik, Marc, thanks for joining us today.
Thanks, Marc.
I think now we're going to go ahead and check in with Christina. Hello, Christina.
All right, welcome back to Build Live. We're in the showcase area now, on the show floor, and I'm actually at the JavaScript and TypeScript booth, and I'm super excited because not only am I here with my coworkers and fellow advocates, Cassie and Jeremy, but we're here with Anders, who is the creator of TypeScript and C#.
One of the creators of
TypeScript and C# and lots of other amazing things. And thank you for being here. This is so cool. I'm not even going to lie. Like, I'm just kind of nerding out right now. I know you two are as well. And Cassie, we were talking earlier, and you're saying, like, you are a C# person.
Yes.
Right? You're into C#. You're not a JavaScript person. But you like TypeScript.
Yes, I love TypeScript because it makes it a lot easier to do full stack development because it streamlines how I do things from front end to back end.
Very cool. And when did you co-develop TypeScript? How long has it been now? How many years?
Well, we got started probably, it went public about 7 years ago, 6 or 7 years ago. Yeah, and we worked on it for a couple of years before that, so it's been a long time by now.
But the popularity, like, it keeps just rising popularity. The adoption
it has grown
is huge.
to numbers that we never would have fathomed possible ourselves. Yeah, but it's wonderful. I mean, and it makes us, it just energizes the team to see that level of adoption and that level of support from the community. Yeah, it's wonderful.
That's amazing. That's amazing. Jerry, when did you start using TypeScript?
I started using it actually the day after a conference presenting a framework. We used Backbone back then. Before Angular and Vue and React. And it came out, and I said, this is going to be huge. So I scrambled back and refactored my whole application to use TypeScript and worked that into the back. So I showed it the normal JavaScript way. I said, but there's this new TypeScript thing coming out, and look what it can do. And I've been using it since then. In fact, one of the most impactful projects I was on was a massive enterprise project. We spent 2 years rebuilding a bunch of different components to a web-based app. And we started out using JavaScript, and we were just having tons of issues. Velocity, for some reason, the customer wanted us to deliver it faster, ahead of deadline. And so we looked at options to accelerate it, and we decided to go with TypeScript. And just converting that existing application to TypeScript, we saw a velocity increase of 4 times.
Wow.
And we were measuring this and tracking this. So I became a very firm believer after that exercise of it.
Definitely. Okay, so you're now going to show us a little bit of a demo of why JavaScript people should be paying attention to this. Or
absolutely.
This, right? And Cassie and Anders, of course, are going to chime in the kind of their comments as well as we go along. So, I mean, you're kind of doing it in front of the type father. So
right. There's no pressure when someone comes up and says, why should I use TypeScript? And you start to answer, and Anders walks around the corner. And you're like, I hope I'm getting this right. But what I like to show people is I start with a very simple piece of JavaScript. And I've got a function that just takes 2 parameters. And what I'm logging back is I'm doing something very natural. I'm saying the first variable, colon, second variable. I happen to multiply that by 2. Now, JavaScript is a very flexible language. That's why a lot of people like it.
Right.
So, of course, what I'm going to type is the answer to everything is, and pass it 21.
Yeah.
But what's interesting is with JavaScript, it's perfectly valid for me to do it the other way. The answer to everything is. And what I love about JavaScript is I feel like it's written with a sense of humor, because if we run this application and we pass it, it says, of course, 21, not a number.
Right.
And it's not a number. And we can multiply not a number by 2, and it's still not a number. That's why it's fine. And so the first thing I tell people is what's interesting is TypeScript is used by Visual Studio Code to give me IntelliSense inside of the code completion here. So if I do foo, it's inspected and figured out what it can, that X is anything, Y is anything. So the first thing I can do, the first step to taking advantage of TypeScript, is I can do something like this with comments and annotate what I'm expecting. So I'll tell it that first parameter is a string, that second parameter is a number. And when I do this, and I come down here and I look at my function, it's telling me string and number, which is great, but now I'm expecting people to read the documentation and learn from it.
I mean, and we know we all should read the documentation, but I mean,
I like things to be automated, so I don't have to keep asking, did you read it, did you follow it? So if I just do this simple comment at the top and tell it to use TypeScript checking, suddenly it throws an error for me, and it tells me something bad just happened. I'm expecting a string, you didn't pass me a string.
And the interesting thing here is that this is the TypeScript compiler checking it, but what you're writing here is JavaScript, and we're just sucking the types out of comments, so you don't even have to compile this to run it.
Right.
You know, it just runs the way it is.
And that's what I have a lot of people ask me. We have a huge JavaScript code base. How do I start taking advantage of TypeScript? And the first thing I say is you can start using these comments, and you already get those checks. But the other thing I point out is that TypeScript is really just JavaScript. So what I'm going to do is I'm going to take this, and I'm just going to rename the file so that the extension is TS instead of JS. And when I do that, suddenly, and I actually moved my comments. I want to keep them there. That's okay. I can throw them back. Let's pretend like we were right here with a parm X of string and a parm Y of number. And we were doing that. So basically, it's starting to give me some hints. It's saying, okay, we're in TypeScript world, but we have some hints. What's nice is if I hover over this, it's looking at those document types. I click Quick Fix, tell it to annotate, and now it's using this TypeScript notation to tell us X must be a string, Y must be a number. Now, at the end of the day, when I have this piece of TypeScript, I can come down and compile it. I'm just going to call the TypeScript compiler, tell it compile the TypeScript in my directory. I get a JS file, and if we look at this, this file looks very much like the JavaScript we started with. So there's no surprises. We're not taking a completely different language and translating it to something different. In fact, the way I used to sort of bait people into trying TypeScript is I'd point out the JavaScript it generated. If for whatever reason this experiment fails, you can take the JavaScript that it generated and actually check that into source control and continue on as if nothing happened. Now, no one has ever done that because there's so many advantages, but that's one of the powers of what it's doing.
Takes the risk out of making the change.
Yeah, no, which is important, right? Because you don't want to be, okay, sometimes I'm using this, what if I'm adding this and it makes some other change? But in this case, you don't have to worry about that.
Right. And the other big thing that's huge is there's support for different JavaScript versions, right? So I may be in one of those organizations where I have to support an older browser version or an older Node version. So
Node, I think, being more prevalent at this point than the browser stuff, right?
Right, exactly.
I mean, because, and their release schedule is so frequent, even their LTS stuff, that, I mean, they just had something go end of life, that if you have something that you haven't updated, that can be a problem.
Well, I never thought we'd see the day that JavaScript would get so many spec updates as quickly as it's getting. Yeah. And so at the end of the day, there's a few things I look at: past, present, and future. So right now, I'm in the past, because this index.js that it compiled, it took a modern feature called string interpolation, which will parse out variables from the string, and it turned it into just simple string concatenation, because that's what the older JavaScript supports. All I have to do is come into my configuration file, and I come up here and I tell it, you know what, I'm done with those old browsers. I want the freedom of being on the edge, so let me go to ECMAScript 6, which is more modern. I'm going to just recompile it. And after that simple recompilation, which is right there, now suddenly it's just passed the interpolation through. Now I said past present, this is present, but for futures, what I've loved about TypeScript is as new features of the language are on the drawing board and not quite released, TypeScript adopts those features. And so I can start using things, even if I'm on an older version of JavaScript, using the conventions that are perfectly valid modern JavaScript. And what happens is when I finally get to switch, and that future becomes the present, then it's just passing through. The code is done, and I've already learned that syntax.
And I think you've shown like sort of the two key value drivers of TypeScript. One is the type checking and the great tooling that you get out of it, and the other is the transpilation of your code that allows you to target different versions of JavaScript in older runtime environments.
Yes.
Right? And so it's sort of a combo of both, but you can actually use it just for one or just for the other.
Right.
A lot of people use TypeScript in combination with Babel, for example, where they're just using the tooling and the type checking, and then they're using a different transpiler or no transpiler at all.
Amazing, amazing. Yeah. Thank you, Anders. Thank you, Jeremy. Thank you, Cassie. And we're going to go back to more content. We will see you later on Build Live.